Welcome. These are the videos to help support your lesson planning process for grade 6. This video will be for lessons 1 through 4, Unit 1, lessons 1 through 4. A video will come out about once a week to cover that week's lessons as you're planning. In these videos, we're going to get a big picture of our upcoming lessons, smooth out any kind of tough concepts, discuss our CFS, and especially focus on what kind of models we might be using to help make it conceptual and making it conceptual. All right, so let's get started with 1.1. I want to highlight the explore on this one. There's actually two explores, this one here, and then this next one here on page 5. The big goal with explores, anytime you're exploring, is to circulate and listen, not to be teaching and showing. You're listening for the ideas they already have so that you can pull those ideas to the surface at the end of the explore time. So think of yourself as hunting for answers and warm calling and looking for things that you can highlight later, not teaching things. You can ask questions, tell them that you're going to want them to say that later, etc. But that's it. Especially watch for things that will play into the lesson of the day. This lesson is about decomposing and rearranging shapes into pieces that are easier for you to find the areas of. So we're supposed to be noticing how this shape kind of fits together. So if you notice a kid say, oh, these two shapes here would have the same area because I could just take this square and move it right over here. You go, oh, that's so interesting. I'm going to worm call you later. I'm going to ask you to tell everybody that here in a few minutes. Or if you have a kid say, you know what, I'm going to bet that this has an area of 9, 10, 11, 12, because look at that. You're going to say, oh, that's so interesting, because they're like, because this is about the same as these areas here. Oh, that is so interesting. You should bring that up later. So that's how you hunt for answers and then worm call. All right, let's get to the I do. So the CFSs that I give you, the criteria for success, are really just to use as a jumping point. You don't have to copy them exactly or anything like that, but CFS can sometimes be a little tricky for people. So the goal is to kind of give you a starting point. So my first CFS for this one is to cut the shape into known, or you might say easy shapes. And so then the question I might ask myself for that is, can I cut or manipulate this into a known shape? So when I'm going to do any kind of like a multiple choice, you might notice this is a multiple choice question. When I'm going to do a multiple choice, a choose all that apply, this is what this is, select all kind of a thing. I'm going to first go ahead and solve, and then I can select all that are true. If I try to select all that are true just from, the vibes, I'm not going to be as accurate. So my first step my first criteria for success is to cut this into known shapes. This little funky shape, not a real great, easy known shape for me, but if I cut it right here, now we've got a really easy known shape. I'm going to label this part A and this part B for clarity. So now my second criteria for success is that I'm going to label the sides and like the base and sides, and I'm going to identify the formulas. So this one's basically already done for me, 3 and 4 and 6 and 2. And I know that these are rectangles. My formula for a rectangle, I'm going to go ahead and give myself a little 4 box down here. In the model area, it's above, so I'm just going to write above here. And then over here, I'm going to put my equation, base times height equals area. So for shape A, my base is 4 times my height, 3. That's going to equal 12. And then for shape B, my base is 6 times my height, 2. That also equals 12. Okay, fantastic. So now I've found the area. Oh, I'm sorry. I forgot to tell you. Number 3, criteria for success number 3 is find the areas of the easy shapes. I just moved on. Here we are. We found the areas of the easy shapes. And then criteria for success 4 is to add or subtract to find the whole shape. So the question I'm going to ask myself is, do I add or do I subtract to find the combined area? The reason we bring this up is because they're going to be seeing a lot of shapes kind of like this one, or maybe a little more like that if that was cut off. So they're actually going to need to subtract something from, like they might find the area of this whole square and then subtract this square. There's going to be a lot of shapes like that coming up, as you can see. But for this one right here, we're going to add these two together because we're trying to find this whole area. So ask yourself, do I need to subtract or add to find the whole shape? I need to add here. So I'm going to be adding this 12 and this 12 together to end up with 24. 24 what? 24 square units. Okay. So next, I'm always going to do a check. And there's a lot of ways you can check, but I'm going to check a specific way this time because I think it really highlights the concept we're getting at. If my stuff is on a grid and it's easy to do this, you can check just by counting. And I'm going to do that because I think it really highlights that an area is literally how many square units are in this shape. So we're going to count up literally how many square units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So for my check, I'm going to count. And there were 24 what? Square units. Okay, fantastic. So I did my check. I did my calculations. I'm missing my sentence answer. This is a good time to go and look at what exactly was it asking me again. The area of the shape is 24 square units. Select all the statements that are true. Oops. So here are the statements that are true. Oops. The statements that are true are... Okay, let's talk about which statements are true. The first statement says the area can be found by counting the number of squares that touch the edge of the shape. The area can be found by counting the number of squares that touch the edge of the shape. Well, first of all, we know that's more to do with perimeter than area, so that's kind of a clue that that is probably not really true, but we could do it. Let's try it. Let's count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Not quite. We've got all these here in the center missing. So that's not going to work. So no, that is not true. It takes 24 grid squares to cover the shape without gaps and overlaps. Make sure to define gaps and overlaps, but this one is true. We can count it up. We can calculate it up either way. The area can be found by multiplying the side lengths of the units that are 6 units and 4 units. Well, that's actually this here and this here. So those are just like opposite sides of the shape. They are, that is not part of how you would calculate it. It does happen to be 24 in this case, but that's kind of like random, if that makes sense. It's not actually how you find it. That won't consistently like get you correct answers. The area can be found by counting. Yes, actually that's one way. That's one perfectly valid way of doing it. It gets a little messier definitely if there's more complicated shapes, but it totally can work. Or the area could be found by finding 4 times 3 and 6 times 2, which is the method we used. So fantastic, winners. Okay, let's move on now to number 2. So this is Unit 1, Lesson 2. And let's talk just a little bit about this Explore. So in this Explore, the key takeaway, the thing that you really want them to catch is that parallelograms have 4 sides and that opposite sides are equivalent and parallel, and that opposite angles are congruent. Parallels have 4 sides, opposite sides are equivalent and parallel, opposite angles are congruent. So this is a good time to just kind of wander around, ask them what they noticed, and then when it's time to kind of summarize up at the front of the room, you get all their attention and say, okay, let's talk about what we found, and ask questions and call on those ones you warned you would call on. Make sure to go ahead and use some of those symbols. This is a good time to introduce them. So be talking about how, oh, look, I'm noticing that these 2 sides are the same, and these sides are the same, and these angles are the same, and these angles are the same. And go ahead and show them the symbols that they can use to demonstrate that. All right, let's take a look at this first I do. Our criteria for success on this, I'm going to say number one, you're going to identify the base and the height of each shape. Now that is actually one thing I like about this criteria for success is that it rolls over into the next day. So tomorrow for lesson 3, you can use the same criteria for success. Today's lesson really is all about learning to identify the base and the height. Specifically, can I find the base and then draw a perpendicular line to that to find the height? Next, I'm going to identify the formula for that shape. So how do I find the area of a parallelogram? And then I'm going to use substitution. So I need to know where to label the sides to fit into the formula. And then I need to calculate the area. Lastly, how do I solve the equation that I wrote? Okay, so let's talk about each of these shapes. Some of these shapes are easier to deal with than others. The first one is pretty straightforward. We've got a base here, right across the bottom, conveniently at the bottom of the page, which feels appropriate for a base, but is not required. And then the height is how tall it is. And you're going to want to talk about, just like when we measure, anything else, we don't measure at an angle to decide how tall something is. We always measure straight up and down. We measure perpendicular to the ground. So whatever side you choose as your base, the height has to be perpendicular to it. So on this other shape here, we've got this side here as a base. Is there a perpendicular angle to it? Yes, there is. Right there. That's perpendicular to it. Okay. If we have this as a base, do we have a perpendicular angle? Yes, we do, right across here. I want to highlight that so far, every single one of these has had this little 90-degree symbol. Why has it had that? Oh, because perpendicular means 90 degrees. It must be 90 degrees for it to be a base and a height. All right, this is where it starts to get a little sticky. If this is our base, what's 90 degrees from that? Well, it's going to be right this way. It's drawn right over here to help with the clarity, to show that this is the height. But this is dotted to help us see that that's not actually part of the base. If this is the base, does this work as the height? No, it does not. That's not perpendicular. Same issue here. That is not perpendicular, and not perpendicular. Even though it has this, if this is the base, then that is not perpendicular to it. Okay, so we know none of these. So we know it's just these first 4. You need to make sure to explain why different ones are incorrect and why they're correct. The emphasis being 90 degrees from the base. Perpendicular. Okay, so then our select all for this one is going to be only horizontal. Only a horizontal side of the parallelogram can be a base. No, it does not have to be horizontal. It just has to be perpendicular to the height. Any side of a parallelogram can be a base. Yeah. A height can be drawn at any angle to the side chosen as the base. No, it must be 90 degrees. Only 90 degrees must be perpendicular. A base and its corresponding height must be perpendicular to each other. Yes, exactly. That's what I've been saying. A height can only be drawn inside a parallelogram. No, you can draw it inside just like this one is, and you can draw it outside just like this one is. Either one is fine as long as it's perpendicular to the base. The height can be drawn outside of the parallelogram as long as it's drawn at a 90-degree angle to the base. Yes, absolutely. A base cannot be extended to meet height. That is false. We can extend the base. Remember, that doesn't count towards the towards how much to the length of the base, if that makes sense. Okay. Let's take a look at this. I guess it's still the extension of the I do, because it gives us a little bit of extra practice filling in, understanding how this relates to area. So specifically, I want to highlight use it as an example because it's so easy. They already know how to find the area of a rectangle. Super easy. So we calculate the base. It's asking us to fill out this 1, 2, 3, 4 is the base. So the base is 4, easy peasy. 1, 2, 3, 4, 5, 6 is the height. Okay, that means our area is 24. This we already know how to do. This part's easy. Ooh, but look at B. There's a parallelogram. This is where it starts to get a little messy. But here's where you can highlight something. Look, I'm going to change colors for this. Make it a little easier. We're gonna cut off this section right here, this little triangle here. We're gonna cut it off and move it. And I would absolutely do this with the students. We're gonna move it right over here. So we just cut off this part right here and we moved it over, and now we've ended up with a rectangle. So this parallelogram, even though it's not actually a rectangle, it has the exact same area as a rectangle that has its height and its base. So if we find the height and the base of this parallelogram, we can do height times base just like we always do for a rectangle. Isn't that crazy? So let's calculate the base first. 1, 2, 3, 4, 5 for that base. And then let's calculate the height, just like we've been learning to do, not following the slant, just from the tippy top point to the bottom point. 1, 2, 3. 5 times 3 is 15, so the area of this parallelogram is 15. Make sure, go ahead and show them the other two. And then the whole point of this is that they're noticing that just like they already learned with rectangles that a base times a height is an area, for any parallelogram, the conclusion they should draw from this is that a base times a height equals an area just the same. Oh, on this, make sure to count your base here and then come out here, count your height like that and show good symbols. Make sure they know that this is not the base. In this case, the base would be over here, 1, 2, 3, 4, and then your height would be from here to here. That's going to be your height. So that's why it's important to go through each of these shapes with them and let them start to see how that really, the same rules apply. They just, maybe look slightly different. Yeah. And then let's talk about number 3. Oops. All right. So the Explorer number 3, the thing you're really trying to pull out with this one is to notice that the cutouts, that there's all these cutouts here. Number 3 has the exact same criteria for success as number 2. And notice that you've got these cutouts, so you're gearing up for subtraction instead of addition. So you're starting to get set up for them to be able to, subtract these shapes out. That's the kinds of questions you're hoping to be able to have them land at and stuff. This has the same criteria for success as point 2. Identify the base and the height. How can I draw a perpendicular line to a side? And then number 2, identify the formula for the shape. How do I find the area of a parallelogram? Which we found yesterday is the same as finding the area of a rectangle, as long as you know where the height is. And then 3, to use substitution. We already know that base times height equals area. We can just substitute in our base and our height, and voila. And then we calculate the area. So now we're actually solving the equation that we wrote. Let's talk about this just a little bit. So we can solve each of these. Now that we've learned how to find the base and the height, we can solve each of these using our knowledge here. Let me make sure I've got the right pen. I do. So if we know that base times height equals area, well, where's our base here? Oh, look, here's my base, and then perpendicular to it is my height. So that makes this easy. Base then is 10 centimeters, whoop, 10 centimeters, times height is 16 centimeters, is going to equal 60 centimeters. Yay! Okay, This one's a little stickier because we might be tempted to say that this is the base. Remember, first thing that we have to do is identify our base and our height. Is this our base? No, because we don't know what the height with this base would be. That's not labeled for us anywhere. But look, if we put this as our base right here, then we have this very lovely perpendicular line that's already labeled at 18 centimeters. So we can say that this is our base and this is our height. We always write our formula first. Base times height equals area. And we know that our base is 15 times our height, which is 8, equals 120 centimeters squared. Oh, I forgot my squared over here. Okay, so you are seeing how this goes. This one is a little bit messy because it's got, because it doesn't have the sides labeled. You have to count them out, but it's not that messy. Just do your little hops. 1, 2, 3, 4, 5, 6, 7. There's our base. And then our height is going to be here to here, right? Or you can measure it here to here. 1, 2, 3, 4, 5. So our height is 5. I'm going to say height and base. Our base times our height equals our area. That means 7 times 5 equals 35. Okay. Always do the little hops like that rather than just drawing a line. It's easier to see what's going on. It's easier to count. Let's talk about, last but not least, 1.4, and out of this Explorer, here we go. Out of this Explorer, I'm wanting to hear how, I might ask like how they found the area. I'm wanting them to be able to handle this one right here. It's a little messier. Hopefully this will be straightforward. Hopefully this first one is straightforward to them, but that second one might be a little messier. So it's a good time to talk about it. We've got a new CFS for this one, but if you want, you could recycle it for lesson 5 as well. Oftentimes back-to-back lessons are covering kind of different angles of the same idea. Really, this whole unit is talking about, different angles of the same idea, but especially some of these back-to-back units, and there's no reason to create a new CFS if yesterday's works just fine. So for the new CFS, I'd start with identifying the shape. So I'd ask myself, what kind of quadrilateral am I dealing with here? Notice all the different shapes on here. Then number 2, I'm going to draw lines, turning it into 2 triangles. This is prepping them to be able to understand how they can turn things into triangles and solve based on that. So the question I'm asking myself is, how can I make this quadrilateral into 2 congruent triangles? And then 3, identify the base and height of the dimensions or of the shapes. Okay. So this I do says 2 shapes are identical if they match up exactly when placed on top of each other. You're going to draw a line to decompose, meaning to break apart, each shape into 2 identical triangles. So let's look at A right down the middle. Voila, there we go. We've got cut in half, identical shapes. If you folded it on that line, they would fit on top of each other nicely. B is a little messier. I can totally cut it down the middle, but you may notice if I just folded it in half, this corner would be there and this corner would be there. That said, if I flipped one of these over, they would still fit on top of each other and they still have the same area. So we're going to count them. This here, there is no way of cutting this that's going to end me up with 1 congruent triangle or 2 congruent triangles. So I'm going to not do that one. This one, if I split it right here, congruent triangles, woot woot. Now, this one I can get into a shape where it's cut in half for sure, but that isn't a triangle. There's no way to cut this one into 2 congruent triangles. So we're going to say no on that one. F, there's my congruent triangles. And then G, here we go, some congruent triangles. Okay. And I also wanted to show this we do here because it's a little bit different. Okay, so this one says to decompose a quadrilateral into two identical shapes, Claire drew a dashed line as shown in the diagram. Let's go ahead and actually do ourselves a little 4-box here. Okay, on question A, she says, it says, she said the two resulting shapes have the same area. Do you agree? Explain your reasoning. Okay, so we're going to say yes or no, I agree or disagree because, and then I'm going to explain that, right? Okay, I'm not going to do a model because I'm just going to use the one that's above and I'm going to just scribble on top of it. Let's decide if these two have the same area. Okay, to find, it's already neatly divided into two shapes for me. Fantastic, thank you, whoever wrote this curriculum. I'm gonna label the triangle shape A and the rectangle shape B. And then I'm gonna go, okay, I'm gonna do shape B first because I think it's easier. So I know to find shape B, I need to use base times height equals area. And I know that my base is 1, 2. So there's 2 times, what's my height? 1, 2, 3, 4. All right, equals 8. So shape B has an area of 8. Let's see about shape A. Shape A has a slightly different formula. Base times height divided by 2, or half of base times height. Whatever. So here's our base 1, 2, 3, 4. Our base is 4, and our height is 1, 2, 3, 4. Okay. 4 times 4 divided by 2. So 4 times 4 is, 4 times 4 is 16. 16 divided by 2 is 8. So we've got 8 here equals 8 over here. All right. So I can count them if I want to. One way to check is to count. I can count this. I can go 1, 2, 3, 4, 5, 6, 7, 8. And then, so shape B equals 8. And then I can count the other side. 1, 2, 3, 4, 5, 6 whole ones, plus a half and a half is 7, plus a half and a half is 8. So shape A equals 8 when I count them. All right. So now I'm going to go back to my sentence. Do I agree or disagree that they have the same area? Nope, they have the same area. So yes, I agree because both have an area of 8. Okay, so that's kind of how we do these, and that is lesson 4. I think it's going to be a fun one. I love geometry, and I hope you guys have a blast with it, and enjoy your first week of teaching.